that you guys, hopefully, you guys have gotten the emails and stuff from the school about what's happening next week. So I think it's loading up now. So the number one thing that you guys need to know is that today is our last in-person class. So if you got the email, you'll understand that the school has decided that next week we should not meet in person due to the rises in infections of the corona. So if that's upsetting to you, I apologize, but rules are rules. And so many of you don't come anyhow, so that's okay. Yeah, so Ethan, Ethan, you just sometimes patience, my man, sometimes patience. So tomorrow, we will not be online per se, so there is no live class tomorrow. So I thought about this. I don't know any of your personal situations. And I don't know. Some of you may have, when you got the email, decided you're going to leave tonight or tomorrow or whatever. So I don't want to, what I'm going to do tomorrow is I'm going to post a pre-recorded video and you can watch it at your leisure. I don't care when you do it. But I would encourage you, if you have questions about it, to please reach out. And then on Monday or Tuesday, schedule a Zoom meeting with me if we can, and we'll have class as normal. So our last class is on Zoom Tuesday at the normal time.
Last lecture or?
Yeah, our last class. What do you mean? That's our last lecture. Yeah.
So some professors like they finish their lecture early.
Yeah.
Then the last 2 days is like for revision or something for the exam.
No, this will be, we'll be learning something new next week. Yeah. So we'll actually learn something. That doesn't mean you can't ask questions. As you know, you guys are allowed to ask questions. I hope you guys get that. I don't, I know some people don't like questions at certain times. I'm happy to answer questions whenever you want to ask them.
And will you upload like the live? You said there's no live class tomorrow.
Yeah, there's no live class tomorrow, so I'm gonna send you a video.
During the normal time or just?
Yeah, it'll probably be up beforehand. Yeah. Does that make sense?
Yep. So
I'm hoping to have it tonight, and it's just basically it's going to be a short little video for you guys. And actually, you guys, the way I ran this course this semester, we're actually in a good place. You're fine, homie. Does anybody have any questions or comments about this? So hopefully you guys are figuring out your personal agendas with everything going on, and I know a lot of moving parts right now. It's very hectic for me. I know it's hectic for you guys. It's not the ideal situation, so we're trying to make the best of it. Look, the unfortunate thing about calculus is, especially in a time like this, is don't forget this is a 4-credit class, and it's also very difficult material to learn. It's time-consuming material. So even if I try to make it less stressful on you, there's only so much I can do. I have to keep the integrity, academic integrity. I have to keep the integrity of fact that some of you will actually use this in other classes, whether you believe it or not. It's funny. I'm getting emails now from former students because they need certain things to get into grad school. And I'm like, I told you fools to listen to O'Grady, but no one listens to me. So they just think I'm a babbling fat man. So, which I am, I guess, but that's not all I am. Okay, so by the way, I wore a nice shirt for you today. Hopefully you guys recognize what it means. If you don't, that means you didn't pay attention to the life bonus that I asked you to do. Yeah?
You didn't get
I just patience. I'll see. Yeah, patience. Who's calling me?
Next time.
Look, this is cute. I got a potential spam is calling me right now. I love this. Potential spam. bunch of craziness. Yeah, I was getting all these weird phone calls. What do you mean you can't see it? Open your eyes, homie. That's exactly right, Muhammad. Exactly. Everybody wants to be a Ray's Boom Boom Room. All right, look. Today I'm getting phone calls from Kansas and Texas. They're probably going to tell me that I owe money or something. It's like, what do these people want? These spammers. They got to spend their time going after old people, not me. I ain't falling for the jiveness. Okay, so let's pick up where we left off, and that is we've been discussing. Oh, no. So you had a question. So Shobit had a question about, and it's a good question. He had a question about these power series things. So here's the question. What's a good way to see the pattern of a series? And here, let me be even more specific. The pattern of a series, so we can write it in summation notation. Or in sigma notation. So I think that's the question you're asking, right? Yeah, so we'll do this real briefly. I'll show you. I don't know that there is a good way to do it, but here's one way that I do it that sort of helps me. All right. Dun, 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 dun. Dun, dun, dun. So here we go. So one of the problems on the homework was to get a power series. What was it? Let's just, here, we'll do a simpler example just so it doesn't take so long. But say we want a power series for 1 minus x squared, right? So the one on homework was cubed, I think, right? Yeah, so the same thing's going to work. So what is this in terms of a power series? So the idea, or is to differentiate the following. So we told you how to do this. We say, okay, let's start with this. And we know this to be true between -1 and 1, correct?
Yeah.
So one idea is to differentiate this, but the thing is, when you differentiate it as it's written, it's not so clear to see what the pattern is. So instead, differentiate it from a different perspective. Now, it might be easier for you to do it both ways and then match it up. So instead, I might differentiate it written in sigma notation already, because we know what this is. This is x to the power k. K goes from 0 to infinity, right? Now, if I differentiate this, the left-hand side becomes 1 divided by 1 minus x quantity squared. What does the right-hand side become? Well, if we already have it in sigma notation, how do you differentiate? What's x to the 10th? It becomes 10x to the 9th. So this becomes k, x to the power k minus 1. Now, we know, what's the first term? The first term differentiates to 0, so we know there's no longer 0. The first term has to be 1. So this now starts from k equals 1 to infinity.
So it would, the first term, it would change to 1 because?
Well, because look at this. When you differentiate this, it's 0. So what's the first term now? It's 1.
Yeah.
So how do you get this to start at 1? You get it to start at 1 by plugging 1 in. Plug 1 in, you get 1x to the 0, which is 1. Does that make sense?
So if you differentiate again, that 1 will become
Well, now if you differentiate again, so do it again.
It becomes 2, right?
Yeah, so, well, be careful. So let's come over here and differentiate again. If I repeat the left-hand side, what does the left-hand side become? Well, think of this, it's useful to think of this thing on the left-hand side as this is 1 minus x to the negative 2. So when I differentiate this with the chain rule, I get 2 over the quantity 1 minus x cubed. And so on the right-hand side, now I have to differentiate again. So this becomes k times k minus 1 times x to the k minus 2. Right? And then, okay, so where does this start? Well, let's go back here. So again, it would be useful for you to differentiate it in this form twice, and then also like this compactly, and you can see, where do you start it? Well, look, if k is 0, this doesn't make any sense because you know the first term is not, right? What's the first term going to be? It's going to be, differentiate this once, you get 1. It's different, and this would be a 2x. You different, it's not it's going to be a 2 actually. So you need this, right? So this starts at 2. Does that make sense?
So for that one, right, the 2 is on top. So what I did, I divided both sides by
Right. So then that's fine. Just then you would put it, if you divide both sides by 2, then this would be 1, and then this would be over 2.
Would it start again by would be 1?
No, it would still start at 2. And by the way, there's no need to do that when look, the original question was, how do you test the radius of convergence? Because you know, for example, we know it's going to be true between -1 and 1, but what we don't know is what happens at 1 and -1. And in order to test that, you need to have it written in compact form so you can use the ratio test or one of your series.
But it's fine to leave the 2, right?
Absolutely. You could just leave it over here because it doesn't affect anything. That's right.
Because the actual question is 1 instead of 2.
Well, yeah, that means you would just put a 1/2 in front. Constants do nothing to affect the series. Only the things that change, like the k's and the x's. Those are the only things that can affect the value of a series. Does that make sense?
Yeah.
Does anybody have any comments about this? So again, the original question posed was, how do you determine the pattern when it's so that you can write it in compact notation? I didn't ask you to do this, but it's useful to know how to do it, and this is one way to do it. So my advice is to do it both ways. Write it all out and differentiate it, but also write it in compactly. Make sense?
Yeah.
Mm-hmm. And by the way, this is, look, one of the learning objectives of calculus is to understand sigma notation and how to use it. So it would not be a mean question for me to ask you to write it in both ways. In fact, lots of calculus exams do that. I haven't asked you to do it yet, but I could. Right? Okay, fun. All right. Any other comments about this? Questions? Having fun yet? It's almost over, guys.
1 more. Next time.
Yeah, no. There's lots left. All right, so moving along, we were talking about differential equations. So let's do that. Back at it. So or let me not say it last. So our most recent topic, or our current topic, is an intro, albeit brief, to differential equations, which I'll use the standard notation diff-EQ. So last class, we showed how to solve separable equations and initial value problems. And so today, well, I guess maybe we should do an example before we learn the new one. So let's do an example before moving on. Or as I like to say, new stuff. Now, the two examples that we did yesterday, the equations were already written so that it was sort of clear that they were separable. There's two nuances here. Not every separable equation can be, first off, not every separable equation, at first glance looks like it's separable. You might have to do some algebra to see that. Second off, not every equation can be solved explicitly because we might not be able to integrate both sides. So sometimes the example or the solution that we obtain is not in explicit form, but in implicit form. So this is an example where we can't determine an explicit solution. So instead, although I shouldn't say we can't, we could if we wanted. So instead, what we do is we write the solution in what we call, if you remember back in Calc 1, we gave names to this in implicit form. So here's one that we'll do. So it's going to be an IVP. Let's take x times y plus 2 dy dx is equal to the natural log of x plus 1. And we want a particular solution that when you plug x equals 1 in, y is negative 1. So this is a separable equation. It just doesn't look like it at first glance. You have to do some work. So what we're going to do is we are going to separate. And when I separate, I'm going to put everything with y on one side and everything with x on the other side. So I have to be very careful with how I do this. This is log of x over x plus 1 over x, and then this is dx. By the way, another way of doing this that might be, well, okay, we'll just leave it like this. I mean, or if you want, I don't know what is more clear to your eyes. You might want to write this slightly differently. I might write this as log of x plus 1 times 1 over x dx. I don't know how your mind wants to think about it. And the reason I rewrote it like this is because I know I'm setting up for an integration. And what I do is I have what's called experience, which maybe you don't, obviously. And I see a log in there, and I also see 1 over x. And that says something to me because 1 over x is the derivative of log. And so already my mind is spinning on how I'm going to integrate. And my mind is telling me, oh my God, there looks like a substitution floating in this thing. I don't know that that's the case, but that's what it looks like to me. So next thing we're going to do is integrate. So on the left-hand side, I'm integrating y plus 2 dy. On the right-hand side, I'm integrating the natural log of x plus 1 times 1 over x dx. And so the left-hand integral is a very elementary one. It becomes 1/2 y squared plus 2y. Now the right-hand one requires a substitution. So what I'm going to do is I'm going to do a substitution. So over here, I'll write my substitution down. I note that I'm going to let u be log of x plus 1. And then my du is 1 over x dx. So this actually turns into be a very perfect substitution. Sometimes textbook examples have perfect substitutions. So this becomes the integral of u du. No, be careful. Yeah. So this becomes, the left-hand side won't change. The right-hand side becomes 1/2 u squared plus arbitrary constant. And then the last thing I'll do is I will replace u with its original variable, which is y. So this becomes 1/2, excuse me, not y, but log x plus 1. This becomes 1/2 the natural log of x plus 1 plus c. So it's a good place to pause and say a few things. So if anybody wants to say something first, the floor is yours. I love giving you guys the opportunity to speak. Oh, yeah, I did. That would be bad. That's a square. Let's clean that. That looks sloppy. My kid told me yesterday when she was doing her homework, she said, my 2's are sloppy and they don't look the same. And I started thinking about that. This 2 looks like a Z. This doesn't. I got to be more consistent. Although context is everything, my friends. Huh?
You start your 2 from down. There's some people who write it like going upwards.
Really?
Yeah.
I don't know how they do that either. Okay, so now notice that there's a square here. So I really can't solve for y. I mean, if you wanted, you could do some crazy quadratic formula nonsense, but we're not going to do that. That just seems like it's more harm than good. So here is our implicit solution. Now, we wanted to know the specific one that satisfies the condition y of 1 equals -1. So does anybody have a question about this to this point? Okay, so this is, remember, we have a name for this. This is called the general solution. But we want the particular solution. So here's what we do. To get the particular one, in particular, the desired particular solution, we set x equal to 1 and y equal to -1. So you have 1/2 times -1 squared plus 2 times -1, right, is equal to 1/2 times the natural log of 1 plus 1 squared plus c. And what you end up getting here is 1/2 minus 2 equals, the log of 1 is 0, so that equals just 1/2 plus c. And so that implies that c has to be -2. So what we can conclude is the desired solution is 1/2 y squared plus 2y is equal to 1/2 times the natural log of x plus 1 quantity squared minus 2. Of course, you could multiply everything by 2 if you wanted it to be prettier, but you don't have to do that. Although pretty is in the eye of the beholder, is it not? Now, of course, you might say, well, what good is this if we don't know what the explicit formula is? Well, that lots of times in the real world, we can't get explicit formulas. That doesn't mean that those x's and y's don't represent some curve, perhaps an important curve. And what you can do is you can go to a computer and program it to graph the curve. I don't know if Desmos can handle this. Let's see if Desmos can get any idea of this, of what's happening. I'm interested. What's that? Well, it does not necessarily. It doesn't have to be two separate ones. Think of a circle, and a circle is x squared plus y squared equals radius squared. They end up matching, right? But if you wanted to draw a circle as the graph of a function, you need two of them. It's the graph of an implicit function, but as an explicit function, you need at least two pieces, right? And that you can learn about when that's the case in advanced courses. And that, notice this guy only makes sense when x is positive, right? So I'm interested to see what happens here. So let's go to Desmos, and let's just write. I mean, we could solve it. If I multiply everything by 2, it gets a cleaner form. It becomes y squared plus 4y equals, the 2 cancels here. So this would be the log of x. Oh, look, it's starting to give us a picture. Plus 1 squared. Well, look at this. Minus 4. Look at this beautiful creature.
-2.
No, we multiplied everything by 2, right? So that's why 1/2 here, and then there was a 2, and then a 1/2 here. So the 1/2s go away. But look at this pretty thing. Wow. I don't know if this is correct. It's likely it's correct, but it's also likely Desmos messed it up. We don't know. But this is beautiful little creature. Look at this. Ooh, 2 pieces, right? And as we expected, it only makes sense when X is positive because this is undefined when X is not. Oh man. I wish you guys would take advanced courses. Then you could.
When X is a minus, right? Like when X is less than.
It can't have X less than 0. Log's only defined for positive X. And let's make sure it matches. We wanted it to go through 1, 1, right? Does it go through 1, 1? I'm sorry, 1, -1? Sure does. What's that? Well, let's plot the point. What was the point we wanted? We wanted the point 1, -1. There it is. So there it is. So every point on this red curve, its coordinates satisfy the equation we just solved. That's how it works, man. Pretty cool. I'm inclined to believe that Desmos got this correct, but just by plotting points. I mean, look, there's a brute force way of figuring this out. If you understand how to program computers, you can just plug in. You could say let X be every number. Say you let X go from say 0.001 to like 1,000 by 0.01, then you can have a computer real quickly find all the Y's and then just plot them.
And then in order, let's say, this is just like something out of the topic, right? So let's say from 0 till 10, right?
Yeah.
And they tell you to find the area of that shaded quadrant.
Oh, that's much more complicated. Yeah.
But
You could do it,
if I
yeah.
was integrating just that function.
Yeah, it would be integration. You learn how to do that in Calculus 3. So the question Shobit asked is what if we wanted to find the area of this region between like, say this point and 10? Well, you'd have to invent, it requires ideas that you learn in Calculus 3. But you could do it. It would probably be very extremely difficult, but you could be, it's unlikely that it would be simple to do, but you could do it. But typically you'd have a computer approximate it. That'd be easier to do.
So when you integrate, will you integrate also the y side or only?
Depends on how you do it. And you might integrate both. In Calc 3, you learn about double and triple integrals. So it's hard for me to explain that right now, but there's different ways of integration than what we generalize the notion from Calc 1 and Calc 2. Yeah, it's can definitely do it. All right, so that's interesting, I think. Questions, comments? All right, so let's talk about another class of equations then, if we will. The next type we want to talk about are what are called first order linear. So what do these guys look like? These take the form dy dx plus some function, which I'm going to call p times y, equals some other function, which I'm going to call q. And what you should note is that p and q are given functions. Now, these types of equations, much like separables, show up in all types of applications. Two ones that would not be hard for you to sort of figure out on your own with a little initiative would be things like loans and finance, interest. Now, we're not going to get into all that. We're interested in the math part of it. But these types of equations, again, arise in many, many applications. So what we'd like to do is we'd like to think about, is there a systematic way of figuring this out? Note in general, this is not separable because I can't get y's by themselves necessarily. So if we think about how we might solve this and use some guessing like we did before, think about what types of solutions would be involved here. So the first thing I want you to notice is if you have some experience, you look at the left-hand side and it almost, not exactly, but it almost looks like something you learned about back in Calc 1. Does anybody have a thought what it almost resembles? So I'll give you a hint. You have a sum, and in the first piece of the sum, you have a derivative, and in the second piece, you have the function. What famous rule does that somewhat resemble? What? Approximation. Are you high? No, approximation. Let's start. There's a P involved in the word. What rule does that look like? Not a power rule. Product rule. That's right. It sort of resembles the product rule. It's not the product rule exactly, but it looks like it. So that's the first thing about experience that's useful. So if we use what I like to call educated guesses, or what I like to call familiarity, or I like to call experience, what I look at on the left-hand side is I look at something that looks like a product rule, and I think to myself, is there a way I can actually make it a product rule? What's that? Well, I can't just make it a product rule. Okay, let me restate that. Is there a legal way, a logical way that I can make that left-hand side actually look like a product rule? Now, what does legal mean? Well, in math terms, that means how do I manipulate the equation so that the left-hand side is a derivative? Okay, so to see, what am I going to factor? I mean, really, the only hope you're going to have here, if you think about the rules of arithmetic and the rules of algebra, the only thing you can think of is that there might be something you can multiply both sides of this equation by. So to sort of maybe see the pattern, it's nice to instead of looking at P and Q in general, let's take a very simple function for P and Q. Perhaps what's the most simple functions for P and Q? What are the most basic functions you can think of? That's not the most basic function. What's the first function you learn about? When you're in 7th or 8th grade, it's the first damn thing you ever plot. Starts with an L, ends with an E. A friggin' line, right? In particular, what lines have the most simple equation of all? Horizontal lines, right? The horizontal line is y equals a number. So perhaps if we want to understand how this works in general, probably the best thing we can do is replace P and Q with horizontal lines. Those are functions, right? So let's take so when I say P and Q are horizontal lines, that means let's say P of X, let's pick a number. How about we say 5? And let's say Q is, I don't know, let's make it 7. All right, very good. 5 and 7. So these are constant functions. That means their graph is a horizontal line. So the equation we have now is dy dx plus 5y equals 7. Now, in this scenario, it's a little easier to guess and check, excuse me, what could be the appropriate thing to multiply both sides by. Well, for instance, I got, what's that? I can't separate. Well, I could, but I don't want to separate right now. Okay, so you're making a point. I could separate here if I wanted. I don't want to do that because then that doesn't show me any insight on the case. Because if 5 and 7 were replaced by functions with x, I can't separate. So even if you want to separate here, that's fine, but that doesn't give you any insight to what's happening. But that's a good point. So what I ask you to think about is use your brain in another sense now. Using reasoning. What do we expect the solution y to look like? And how do we get any information about that? Look at the left-hand side of the equation. Do you know any function that if you take a derivative and then you multiply the function by the number 5 and add them together, you get 7? Well, let's start eliminating things. It ain't going to be a polynomial. Why? Because if you have a polynomial, the left-hand side would be this. If a polynomial was, say, of degree 5, then this would be, this would be 5x to the 5th something. This would have x to the 4th. That can't add up to a number. So polynomials are out of the question again. Sines and cosines might be in there, but just like with separable equations, when we first alluded to how to guess and check, what is the most likely candidate for what this is going to be involved here? Huh? Quadratic? What are you getting? You're just saying things. No. What type of function is very likely to be involved? Well, just like in the previous examples, the exponential function is very, very common. Why? Because it's the only guy who, when you differentiate it, you get the guy back. Exponential functions have a very, very beautiful property that when you differentiate them, the original function is part of the derivative. And that tells us that it's likely to be involved because the only way this left-hand side can add up to a number is if it's in there somewhere. That's the only way. Now, there might be other creatures in there, but E has to be somewhere, or that left-hand side can't add up to a number. Okay, so the next thing I want you to go to is go back to what did we say about the product rule. The left-hand side, here's the cool thing. You made this point, Shobit, on Tuesday. You said, why don't we just integrate? Well, that only works in the simplest of cases. However, if I somehow made this left-hand side look like a derivative, and if a derivative is equal to something that I know how to integrate, then I can just integrate. So here's the thing. Interesting observation. If we multiply both sides by e to the 5x, we get magic. Now I'm going to put magic in quotations because it ain't magic really. It's very natural because of the 2 points I just made. Now, we're going to tell you why it works in a second. So let's actually do this though. Let's multiply both sides by e to the 5x. And again, this is just a guess I had based on my experience. Now, you might say, well, how do I have experience? Well, guess what? At one point in history, somebody just made a guess, and he was the first, or she was the first person to guess that this works. And then they wrote it up and told the world, and then everybody kept teaching it and putting it in books, and now we're here. So it ain't magic. It's an ingenious guess by somebody at some point that happens to work. Just like those two not weirdos, I shouldn't say that. What were the guys who figured out how to fly an air? Not figured out. The first guys to get the airplane to stay in the air for a while. What were their names? They were from Ohio, and then they moved to the Outer Banks in North Carolina. You don't know who the first two brothers called the Wright brothers? They don't teach you that back home? No, probably back home someone else invented an airplane, right? That's a good point, right? Back home in Kenya, who invented the airplane? It wasn't the Wright brothers, I bet, right? See, it's amazing. Like, do you think in China the Wright brothers invented airplanes? What do they always say though? To the victor, not that You know, everybody writes their own history, right? And then we don't even know if it's true. I always say, if I was studying World War II in Germany right now, I'm sure they ain't teaching 10th graders the same damn thing they're teaching 10th graders in the United States of America, right? I'm just a messenger. Things that you should think about, though. Here we go. This is how I steer conversation. You guys never want to talk about math. You just want to talk about life. I don't even know if it's the mainstream media. I'm not even blaming anybody. I'm saying that everybody gets to write their own history, right? More importantly, to the victors, right? The victors get to write their own history. Yeah, I don't necessarily think that everybody believes the mainstream media. I think most level-headed people think it's all full crap. But I'll tell you one thing, when I was in 4th grade and they were telling me that the Pilgrims and Indians were best friends and they had Thanksgiving, I knew that was bullshit, right? But that didn't stop. See, you don't get that in Kenya, right? You don't have the Thanksgiving where they talk about the Pilgrims and the Indians. That's an American thing. I remember asking Mrs. Gallo in 3rd grade, I said, where are all the Indians, right? I said, where are they at? Now, these are American Indians. They're Native Americans, not, Indians from India, of course. No, I mean bullshit. You're allowed to say bullshit when the hypocrisy is so thick. You can taste it, Emily. This is what you're allowed to do. And so, you don't die. But it is funny if you think about it, like the lies we tell kids. And then, and is it, that's what, as I used to say, there's a great line in another great math movie called Good Will Hunting, where they're talking about Ramanujan, who was a famous mathematician from India. And they say Indian, dot, not feather. And I don't know if that's a racist thing to say. I don't know. Like, because American Indians, it's always that they have feathers in their heads or something, whatever the hell it is. This is what was in the children's history books. This is not even history class. I'm over here giving you, what did the conservatives say? That liberal professors indoctrinate Indians with their liberal, what do they say I am? A liberal messages. All I'm doing is to ask you what you think about Thanksgiving, right? But of course, the Republicans say, do not mess with the American history, O'Grady. This is America, and that is our history. And the Pilgrims and Indians were good friends. This is what they say when the Pilgrims landed on Plymouth Rock. Anyhow, back to math. Man, I should be a 5th grade teacher. Can you imagine? All right, back to magic. I'd have been fired hours ago. We are all best friends. So I'm going to multiply both sides of this thing by e to the 5x. So if I do that, I have e to the 5x times dy dx. And then I'm going to have 5e to the 5x times y. And then on the the right-hand side, I have 7e to the power 5x. Now, of course, to you guys, the untrained legends, the amateurs, this looks like it's more of a mess than we started with. But it ain't. Because the left-hand side is a Calc 1 midterm question. This is the derivative of something. This, believe it or friggin' not, see, I watched my mouth there. This is nothing more than the derivative of y times e to the 5x. That's it. If you don't trust me, go back to Calc 1. Take this derivative. And of course, this thing is just itself. And so the magic gives us, but it ain't really magic, it's awesome logic. Not the wrapper. This says that ye to the 5x prime, the derivative is just 7e to the 5x. And this is a party. There is nothing more you can do besides party, because this is the best damn news we ever seen. Because now we can do what Shobit wants to do all the time, integrate both sides, and we're done. The The left-hand side is a derivative. If I integrate it, it disappears. Well, I don't say it disappears. I'm just left with what's inside. And then the right-hand side is a very simple function. I know how to integrate. That is also calculus 1 level math. Have a party? So why is this a party? Because now all we have to do is integrate. By the way, does anybody have a comment or a question about math, not about the hypocrisy of the Thanksgiving holiday? We do get to eat lots of good food and watch football, which I do like. And there's a parade. Well, they have a parade this year. They're canceling everything because of the Roni. All right. So look, here's what we can do. We can integrate both sides. And the fundamental theorem of calculus says that just y(e) to the 5x is equal to the integral of 7e to the 5x dx. Why did I kill the derivative on the left-hand side? Because the integral killed it. I didn't kill it. Oh my God, there was a good observation about Thanksgiving in that. What happened to the derivative? The integral killed it, pushed it away with guns. I said, you go there. Boy, I'm on a roll today. Oh, Grady. It's a damn shame that this will be on YouTube and no one will see it. This could be viral when I insult the history. Let's just buy a little Louisiana Purchase. So the right-hand side will stay the same for a moment. Excuse me, the left-hand side stays the same. The right-hand side integrates real easy. This just becomes 7/5 e to the 5x plus c. And now I can solve for y because I can divide both sides by e to the 5x and I'm left with 7/5 times 1 plus c e to the negative 5x. And I just killed a bunch of birds, or never. Damn, I was going to have another good joke. Although it's not a joke. This is how we deal with terrible history. We make jokes about it to get students to think. Aren't you glad you came to America, Chauvin? You would have never had. There's no way you'd have had this kind of fun in other countries. I ain't no way. I have a Boom Boom shirt on. Can you believe this? Yeah, we got to get you some shirts. We'll start having shirts. What I'll probably do. Yeah, good luck. Well, now I'm not allowed. It's illegal. We'll do next semester. We'll have giveaways. We'll have shirt giveaways all the time. We'll do it like old school. We'll put your scores up on Canvas so everybody can see. We'll rank you like football and basketball teams, right? We'll keep score, and then the highest, weekly score gets a T-shirt O'Grady made. Why is it negative? That is a great question. So I'm dividing both sides. So notice this e to the 5x disappeared because when I divide it, so let me go a little slower because I'm glad you asked that because here I am being a jerk and acting like you guys have experience. So if I divide both sides by e to the 5x, I get e to the 5x over e to the 5x, which is 1. And then this is c over e to the 5x. And of course, we can clean this up. We can just say y equals 7/5 plus c. And if I take it upstairs, it becomes negative. Does that make more sense? Sometimes I forget your algebra skills, gang, are suspect. Yeah, but your Spanish game is up. I don't know what sus means. Is that some new thing that the kids say? I don't know. It's a game?
No, it's a game, so they use that word.
Oh, okay. I don't know these things. The only game I played, I've been playing GTA again, shooting up the cities and stuff like that. Anybody? And Red Dead Redemption. Oh, you're suspect. Okay, okay. Okay, That's like it's okay. Like people say I'm jelly or purple alert. Or, I can get with the slang. You're suspect. Sus. I like that. I like it.
Are you going to get the PS5?
No, I ain't. Well, maybe whenever GTA comes out for the PS5, I'll get it. What's that? That is, but I mean, no, not. I want whenever they have a new GTA come out. That's when I buy the new systems. When the newest Grand Theft Auto comes out, that's when I'll buy it. I've been playing Grand Theft Auto and Red Dead Redemption, but the Cowboy one, I don't get music. So like, I like to get in GTA and I get in a car, particularly a cab, and then I put the rap channel on and then I let it drive me all over the place. Then I've been getting that hot air balloon too, not the hot air balloon, the Goodyear blimp. And I like to float around the city and then jump out and kill myself. Although, shouldn't say that. When I was a kid, they said that these games and the music would make me a terrible person. And look at me now, right? Were you guys like when you were kids, your parents say don't listen to bad music and don't play games because they'll like make you bad? Yeah, okay. Sure, that's really what makes us bad. Uh-huh. Could I keep the E to the 5? Oh, yeah. You could definitely do that. If you wanted to, are you saying if you want to keep this? I don't care. That's fine. But most people are going to write it like this. It's just more common. Make sense? All right. So here's the thing. What we just did, this trick of E to the 5x, this was not an accident. It works all the time. Now, E to the 5x doesn't work all the time, but there is a pattern here. So how did I get this 5x? Well, what you always do, the trick is to look at whatever's right here. And you look whatever's right here, whether it's 5 or a function. And you take E and you raise it to the integral of this. That is the trick. And so textbooks want you to know that, so they give it a name. They call it an integrating factor. And I think that's stupid, but who am I? And I should not say that. My kid yelled at me this morning. Say that again?
I know a number, right? That function will always be a number. It can be
No, it can be it can be anything. It can be anything. So we're gonna write that down. It could be scary. So here's the thing. So the magic trick ain't. Let's be real bad English. I like this. Ain't no trick. As the great Professor Leonard at Pitt would say, it's a trick if it works once, but if it works more than once, it's a method. And here it is. To solve dy dx plus px y equals qx, multiply both sides by e to the power of the integral of px dx. So that's how I got that e to the 5x. I integrated 5. What's the integral of 5? 5x. That's how I got e to the 5x. It always works. So it ain't a trick. It's a method. We're having fun today. You guys having fun? I'm so sad this is over. This is why, what if people stop coming to college and I have to go get another job and I can't like have excitement about teaching awesome stuff. I have to go like sit in an office and work at a bank, crunch numbers all day, write computer code, the hedge funds and so forth. Yes.
You multiply by E.
That thing, e to the 5x dx. We're going to do another example, so slow your roll. See, that's my slang. Slow yo roll. If I were you guys, every morning I'd wake up and say, thank me, or thank your whoever in your life said, go to La Roche. Because where would you else have this much fun in calculus too? Nowhere. But if you would have stayed back home or went to England, you'd probably have some person in a suit and tie and blah, blah, blah. No, you have this. This is pure, authentic, awesome love of math. Huh? Oh my God, my Amazon delivery just came. Yay. What were you saying? Did you have a question?
Yeah.
What's your question?
So let's say P of x for previous question, right? It was 5, right?
Yes.
If you integrate 5, you get 0.
Huh? Slow down. If you integrate 5,
You get 5 back.
thank you. Thank you. Thank you. And notice we don't use the plus C because it's just a number. It doesn't matter. You don't need the plus C. Oy vey. So this works all the time. Let's do another example before we leave. I'm having fun. I'm going to miss you guys. This class is fun. I think I can't really rank you my favorite this semester, but I think had we been a normal class and we'd been in person, you guys easily would have been the best class. Right? You would have been. It's close. You're tied for like first. Maybe it's like 1A and 1B with another class. Yeah. See, that's the thing. I like who's my fave. It's tied between you guys and my discrete math class. It's tied. Calc 1, no one talks. No one shows up. And then my prob and stats class, which I do love that class, but I don't know any of them the way I kind of have grown to know some of you. You know what I mean? It's just like, it's what it is. Good times, though. All right, so let's do an example of how this works. Let's say dy dx equals, I keep saying equals. I don't want it to be equals. So plus, say 1 over x dy equals sine of x. Oh, that should be y, yes. Here I am flunking. I almost wrote dy again, matter of fact. What is wrong with me? Oh, vey. Okay, so here we go. Let's think about how we can solve this. So here, the magic trick is e to the px dx, which in this particular problem, what is p? P is 1 over x dx. Now, what is the integral of 1 over x? Please integrate this time, Shobit, not differentiate. It is the log of x. And then we have a very beautiful property that e to the log is what? They're inverses, so this just simplifies down to x. What a beautiful time.
I wrote that someone erased it.
What do you mean they erased it?
I wrote it that you won.
Oh, did they?
Yeah,
They
I
erased
did
it?
that, but someone-
Who would erase it? What criminal would do that? We should have a secret camera out there and then we will assassinate. Or is it an assassination? That would be a homicide. Like, how famous do you have to be before it's called an assassination instead of a murder? Like, if one of you were to kill me, would it be I was assassinated by you, or would it just be you murdered me? Things I think about. Have you ever thought of these? Yeah, I used to say things like, you know, these things cancel each other out or they go to war and kill each other, but then people said that's insensitive, so I don't know. By the way, if I'm saying anything that offends you, you're allowed to tell me and yell at me. The point is to keep your attention, not to offend you. Oh boy, here we go. By the way, the fact that this is chat, that's my point, Mohammed. I need to know. Like, do I have to be the president to be assassinated? Can like a professor be assassinated is what I'm saying. Questions to ponder. All right, so now what we're going to do is we're going to multiply both sides by this thing. Why no? I don't know, Alex. That's the question I'm asking. What is the definition of a public figure? These are the things that I ponder every day. Okay, so let's multiply both sides. Hey, if you guys ain't having fun, too bad, because I am. So when I do that, I'm left with x dy dx plus y equals x sine of x. Or if you would like to note, the left-hand side is really just xy prime. Now notice I wrote this x in front because this is not y of x. This is x times the function y. So this is something that you got to be careful. This is x times the function y. So think about this. If you use the product rule, what's the derivative of x? It's 1 leave y alone. You should verify for yourself that this is in fact this.
It's always, whenever you do like this, will it always be?
It's always going to be, it's always this creature times y quantity prime, always. Now you could check it for yourself each time, but you can trust it if you do it correctly, it is. And you can actually show that. I just don't want to scare you. I could do a problem with P and Q in it, and you would see that it works, but that's just way too many symbols for a Thursday afternoon when you're just a little peasant in Calc 2. You know what's even more badass? There's a theorem that tells us that the solution we find is unique. Believe that. Not that we care in Calc 2 about that. What's that?
What's the name?
It's called the Picard. Well, it's a couple ways you can think about it. Some people, the algorithm for is the Picard iteration, and the theorem is the Picard-Lindelof theorem, I think. Let's Google it. Let's Google it. Let us Google it so we can teach you advanced mathematics. I mean, let's start with the Picard iteration. Big theorem is called, there it is, the existence and uniqueness theorem. See, Lindelof theorem. I was close. Look at this. A first order initial value problem has a unique solution provided certain continuity. Look at this. There's this big thing called the Banach fixed point theorem. Things you can learn about. What is this used for? So in general, okay, that's a great question. So what is this used for? This is used how we solve real world problems that aren't easy. So the problems we're doing in class right now are ones that we can solve by hand. These are concocted problems. Not concocted in a sense. There are many, as I said to you on Tuesday, there are many real world things that happen that we can model with basic differential equations. The fact of the matter is, though, many things are not ones that we can solve by hand. So what do? Well, we use this theorem to go to a computer and approximate the solution. Does that make sense? Make sense? So that's how you would use it. And it's based off this big general thing called the Banach fixed point theorem. Stefan Banach, what a famous mathematician this fool was. And you can learn all about this stuff. Look at this. This scares you. Yeah, it is. But it's awesome stuff to learn. Don't you want to learn all this? Of course you do. You should all go aspire to be PhDs in mathematics. All right. Back to this. Now, notice I have to do two things when I concoct these examples for them to work. I have to pick this function so that I can integrate it, right? And then I also have to choose, I'm going to have to integrate this now. Now, this is going to be an integration by parts. But if I just haphazardly selected a P and a Q, this might be impossible to do by hand, and this might be impossible to do by hand. So that is when you need to use the theory that tells you it's there. So if you go to the computer, whatever the computer simulates or whatever approximation it gives you, we know that it's the right one. Does that make sense? Okay, so let's use the integration stuff now. So next, integrate. And that means the left-hand side derivative is removed by the FTC. So what I mean by that is we're just left with x times y equals the integral of x sine x dx. And so this guy requires parts. So this is good practice for what's going to happen in a week or so with you guys. So let's do it. This guy requires parts. We'll let u equal x, dv equals sine x dx. So your du is equal to dx. And then v is negative the cosine of x. So this is like nightmares of things you haven't done in a while. So this is, hey, we'll even put the formula in for you. UV minus the integral of V du. Of course you have that memorized. So this is negative x cos x plus the integral of cos x dx. And this simplifies to negative x cos x. What's the integral of cosine? The integral of cosine is sine. And then we get plus c. Does anybody have a question about that? So now look what we can do. We can divide both sides by x and we get our solution. So let's put it over here so we don't have to put it on another page. We'll split this all up. So what is the solution? The general solution is that y equals, I'm going to rewrite it. I'm going to write this as sine of x over x minus cosine of x plus c over x. Or Emily, if you want, c raised to the power, or c times x to the minus 1. But I'll write it like this. Say that again.
Do we use minus 1 again?
Well, I didn't. No. I didn't give any initial value. So notice that this solution is undefined at 0. But that shouldn't shock us because look at the original problem. The original problem was 1 over x. This doesn't make any sense at 0. So all right, that was fun. Overwhelming, but fun. You guys have any questions about this? Comments? I know we're out of time. Someone wants to say something. I love this. Homework 12, question number 1. I can. Let me pull that up this way. Say that again. Is that the Faust one? Oh yeah, it's a good problem. Well, they fight, right? Isn't that what those two numbskulls do?
Wait, so just before you, like for me, I say that Taylor series is a specific type of power series, right?
Yes.
It's true to say all Taylor series are power series.
Correct. Yeah. Oh, what did I just do? You said number 12? No, on homework 12, you said, which one did you say? 1-1. I already lost it. I'm sorry.
Homework 12 question.
Question number 1, part A, on homework 12.
You already.
Yeah. It's technically 12 and 13. It's worth 10 points. I'm trying to get you guys free homework points. So hopefully you'll turn the homework in. So you're talking about dy dx equals e to the x1. I think this is what you're talking about. Yeah. So you have dy dx equals e to the xy. Don't overthink this one. Note that e to the xy, how do you handle this? Can you handle it? Is it separable? The first thing you need to do if you want to solve a separable equation is make sure the thing is separable. Now, of course, if you want to yell at me for being a jerk and asking you to do something that possibly can't be done, well, then I will say I'm sorry. But is this thing separable? Because if it ain't separable, you ain't solving it. So it turns out it's not. No. Thus, we can't solve it by separating. So that is a good question you asked. And there was a reason I did. The other two, in fact, are separable, though. At least they're supposed to be. I don't think yeah. The other two are separable, yeah. Mhm. What's that?
You take the x squared, y squared, the other side and factor it.
Yeah, this one you have to do some algebra. This one, part C stinks. Not, I was going to say stinks. Part C is a very important type of equation. This is the logistic model I was telling you guys about. This requires integration by partial fractions. When you separate, I mean, it's already separated for you. You just have to rewrite it. So
at one point you have dx with 1 only, right? Dx without 1 over.
Oh yeah, it would just be, you can leave the 0.05 there if you wanted. Right, so I think the question, so Shobit asked so first off, you don't have to do C. The point is for you to recognize that not everything's separable, right? So you can write not separable. That's all you have to do. Now, by the way, I won't do that on the test. I'm not going to ask you to do something on the test that can't be solved. I've said this to you before. Right? Okay, now for C, let me just make this clear. For 1C, this requires partial fractions. So if you separate it, what you end up getting, here's how I would do it. I would rewrite it as 1 over 1 minus, what is it, 0.02y, and then this is times y, dy, and then I would leave it as 0.05 dx. That's just how I would do it. You don't have to do it that way. Because when you go to integrate it, this one's easy, obviously. Obvi, as the kids say. This guy, partial fractions. So this one's a challenging one, but it is an important one. So that's why I asked you to solve it. Any questions, comments? Anything else? And again, feel free to have any questions you want on Tuesday. I'm completely happy to answer any questions. All right. So my advice for you would be go through the homeworks, particularly the ones since the midterm. Not that we can't ask you anything earlier, but I don't care which ones you look at. If you know how to do all the homework problems, you'll do well on the test. So if you're stuck on certain things, write it down and ask on Tuesday, and then email me and schedule a meeting. There's not classes finals week, so it shouldn't be hard for us to Zoom if you have questions. All right. Any other comments, questions? We're a little over time, so we got to get going. All right then, gang. Thank you very much. Be safe and good luck on any exams, and be safe and enjoy whatever it is the Roni allows you to do. Take care, guys. Thank you very much. And then it is.